Question for this week is, what determines emission intensity?
As a reminder, emission spectra graphs wavelength in nanometers against intensity. The intensity is what we will be looking at this week. Emission intensity is proportional to the number of photons emitted at any given wavelength. Can be used to determine characteristics of most and least common emissions. In an emission spectra, the peaks and the dips between them tell us a lot about the substance. In our data, one thing we notice is that the peak for green is higher than the peak for red. The reaction that occurred involved equal amounts of dye and activator being mixed together. The energy produced by that reaction was equal for both dyes and caused them to fluoresce, meaning that the dyes were able to absorb the energy produced, causing electrons to be excited and photons to be emitted when these electrons relaxed. If equal amounts of energy are being put in, but different dyes have different intensities, that means something other than the energy put in must be at least in part affecting intensity.
If you compare the peaks of pure red and green dye, you'll notice that the red dye has a slightly wider peak with a range of 170 versus 140 for green. Additionally, the peak for red does not come to as much of a point as green, indicating that for the red, the wavelengths around lambda max have an intensity more similar to lambda max than green.
If you look at the structure of red and green dye, you'll notice that red dye has many more bond types than green. Since different bonds and atoms have different energy levels, each one of these bonds will contribute several unique energy levels, thus being responsible for emission at several wavelengths and causing red to emit over a wider range.
This information can be related to shopping. Rose has many different items she wants to buy, whereas Gina has fewer items. If they both have the same amount of money, Gina will buy more of each item and less types of items, whereas Rose will buy more types of items and less of each. The amount of any one item that she has will be less than what Gina has. If Gina buys her items in very different quantities, it would cause a sharp peak, and if Rose had hers more even, it would cause a more sloping peak. Differences in prices would also account for total amount bought.
This would work the same for emission. If photons are being emitted in a wider range of wavelengths, each wavelength produces a lower portion of the energy provided. This logic also works for the mixed dye. When red and green have access to the same amount of energy, red has a lower intensity. However, when red and green are mixed, red's intensity increases and green's decreases. As you can see, in absorbance, red has a peak at just above 500 nanometers, which is exactly what green emits. Red can absorb these photons, which increases the available energy. It also appears to lower green's intensity, as some of the photons it emits gets absorbed instead of reaching the detector. It would be like Rose returning some of Gina's objects and buying more of her own.
In conclusion, emission intensity is affected by both energy input and dye structure. You can see in this graph that as energy runs out and input goes down, emission overall goes down. However, the emission intensity of the dyes relative to each other has much more complex causes, such as bond types in the molecule.